Hi everyone. Today we will have the review session. I have already uploaded the slides for today's session in the shared folder. Apart from like that's what I'll solve in the live session today. But apart from that, if you have any questions, please type it out in the chat box. I'll just be back in 2 minutes. Actually, I had another class just before this. So just give me 2 minutes, and I think a few minutes might also join in a few minutes. So in the meantime, please just type in your questions in the chat box and we'll start. Okay. No questions. Okay, then I will start with the questions I have. Just give me a moment. Yeah, the folder is not empty. You have to look in the folder called review session. Week 12 is going to be on Tuesday. That folder is probably empty. But today's session is not week 12. Today's session is the review session. So can you check again? Let me just connect my iPad. Were you able to find the file? What is not there? I think I uploaded everything. I'm not sure what you're not seeing. I have uploaded everything. Week 11 is also shared. Review session is also uploaded. I'm not sure why you're not seeing. Just refresh it if you're not seeing it. Okay. If you're not seeing uh, the files, please refresh Google, because a lot of times Google doesn't kind of show the files even after it being there. It's not from Swayam. It's that shared folder. It's the Google shared folder which we have been using since the beginning of the class. I think the link for the shared folder is there in the Swayam portal, but that is a folder we use every time. It's not a separate folder. So this is a Google shared folder. In this you have week-wise everything. Except for week 12, everything else is there. Even week 7 is updated actually. So week 7, the last question, the PDF with the last question was I think not there. It was missing earlier. I updated that also. So all previous course materials have been updated. Please see the link I've shared and tell me if you can see it. Okay. Although today it's not anything that pictorial that you needed, but I'm sharing it anyway. So, okay. So I have tried to take one question from each week's content, or sometimes the topic continues over 2 weeks. I've tried to take one question which captures most of the concepts um, across the 2 weeks. So there is like a lot to cover. I can't actually cover everything, but I've tried to cover most of the slightly important or tricky or difficult concepts in this. So this is the first question where you are given the demand for two types of buyers. One is the, you have sent me something. Looking at the instructions for scholars, you have to look at the public sheet. There is a second tab at the bottom. Harmoil, you've shared the screenshot, right?
Thanks, ma'am. I got it from the link. The link that you shared,
Yes,
that's
even
working.
in the spreadsheet which you have shared, what you are looking at is instructions for scholars. That is not where you are supposed to look. There is, look at the bottom, there is a public sheet. There is a separate spreadsheet. That is where I have updated
Roger, Roger,
the
Roger, ma'am.
links. Yeah. Okay. Okay. So the first question is where you have the demand function for two types of buyers. There are urban buyers and there are rural buyers. And you have to find out the market demand function. So can anyone tell me what we will do in this situation? How will you find the market demand? Or if you can tell me what is the thing you need to be kind of careful of in this type of a question. Anyone wants to attempt? No? Okay. Hmm. Okay, so let's go with question 1 first. Let's see what the deal is. So Q1 is demand for urban buyers, which is 100 minus P, and Q2 is demand for rural buyers, and that is given by 60 minus 2P. Now, the key thing when you're deriving any demand function is that you have to make sure always that Qi, whatever, I've taken only two. It can be any number of different, it can be set of 5 groups of people. You can have something like Q1, Q2, Q3, whatever number. Okay, let's say Qi, different groups of people or buyers. I'm explaining the general case first, just so you understand how you have to approach these kind of questions of buyers or consumers. And you're given their demand functions and you're asked the market demand. So yes, summation Qi gives you the market demand such that Qi is greater than or equal to 0. So this such that greater Qi is greater than or equal to 0 is the important condition which you have to remember. That is the main thing I wanted to show. Just give me a moment. Yeah. So now in this case, what this means is that, we have Q1 and Q2. So we have to first impose the condition that Q1 is greater than or equal to 0. For the sake of clarity, let us remove the equality for now, because equal to 0 just means no demand, which is not really saying anything at all. So if Q1 is greater than 0 implies, wait, let me rewrite this. So let's plug in the value of Q1, it's 100 minus P is greater than 0, which implies that P is less than 100. So the first group is going to have any demand only as long as price is less than 100. At price equal to 100, the demand is 0, right? So this is the first condition. Let's call this 1. And Q2 greater than 0 implies 2 is what? 60 minus 2P is greater than 0, which implies P is less than 30. So for the second group, they are going to have any demand only when P is less than 30. So we can make, let's say we can make 2 slabs, right? Q is equal to, for P between 0 and 30, it is Q1 plus Q2, right? Because less than 30, the second group also has demand and first group also has demand. Both the conditions are met. For the first group, P needs to be less than 100. For second group, P needs to be less than 30. So both are met. So between 30 and 0, both are going to be having some demand. For P greater than 30 and less than 100, the demand is only Q1. Because only for group 1 the condition is met, for second group it's not met at all. So for and here somebody did ask this question when we were having this discussion in the class. You can put equality here or you can put equality here. You don't have to put it in both the places, but you can put the equality in either of the two places, because in both the places the Q2 is anyway 0 at P is equal to 30. So if you put equality or you don't put equality in either of the both the cases, it's the same thing, right? So this is the second slab, and the next is P is greater than 100. At that demand is 0, because even for the first group the condition is not met. Therefore, now you can now you can add, now you can do the horizontal summation as we normally do. Q is equal to Q1 plus Q2 is what? 100 minus P plus, that's the second one, 60 minus 2P, right? 160 minus 3P for P less than equal to 30 greater than 0. Second condition, it is 100 minus P for P between 30 and 100. The third is 0 for P greater than 100. This is the final answer. So in this, I have given a very general question because I wanted to kind of go through the whole rationale and the approach in these type of questions. But in your assignment or your quiz, you could be just given the price and you could be asked that what is the market demand function at this price, or what is the market demand at this price. So you have to be careful. If you're given the price, you have to see which slab the price is kind of fitting in. You put this as QD if you want. Generally, that's what we denote it as. Okay, so let's go to the next question. Any doubts in this? Can I move on? Any doubts? Can I go to the next question? Okay, I'm assuming nobody has doubts. Okay, so the next question is where you are given the market demand for rice and we're given the market supply for rice. And you are asked, first of all, to find the equilibrium quantity of price and, equilibrium quantity and price of rice. So, does anybody want to attempt it? It's pretty, the first part at least is pretty simple. Any ideas? If you want, I can mute myself. You can solve it for a few minutes. I think first part at least everybody can solve. Yeah. Any answers? Price and quantity of rice in equilibrium. Okay, the demand is given by P is equal to 1000 minus 2QD, and supply is given by, this is the inverse demand and inverse supply function. Okay, yes, some people have answered and I think it is correct. Let me just check. Chitu. Sorry, my cat is jumping all over the desk. So if something goes amiss, please know that that is what it is in case we lose connection or something in the middle. Yeah, I think your answer is correct. P is 400 and Q is 300. Okay, so this is fairly simple. In in equilibrium, we have what? QS is equal to QD. So QD we can say is sorry, not P. 1000 minus P by 2 and Qs is equal to 100 minus P. Therefore, 1000 minus P by 2 is equal to 100 minus P. Did I do something wrong? Why am I getting a different answer all of a sudden? What did I do wrong? I think I did something wrong. I think I wrote something wrong.
Ma'am, it is 100 minus P, ma'am. You have written 200 minus P, I suppose, ma'am.
No, I've written 200 minus 2P, which is 2 taken to the side. Okay. I have done something wrong. Hang on.
Ma'am, you didn't need to divide it by. Okay. Ma'am, couldn't we put it straight only 1000 minus 2QD, 2Q is equal to 100 plus
Yeah, you
Q?
can do that. I mean, it should work out either way. You can equate price also, that is fine. But I think I was making some mistake. I'm not sure what. So this becomes 900. Yeah, I had written I had got some sign flipped. That's why it was coming out to be wrong. But I wasn't being able to see what exactly I had gotten flipped. Anyway, so this is P is equal to 100 plus Q is equal to 400. I wrote some sign like reverse. Instead of plus, I wrote minus or something like that. Anyway, so the initial part is pretty easy. This is just the first sub part. This is, let's write this down. Q star P star. Okay, let's go to the second part, which is the more interesting question. So the second part is that now the government wants to impose a price floor of P, or you can write it as P bar, equal to 500 for rice. So now what is the quantity traded and what is, I mean, the price? Price anyways, it is price floor is 500. But what is the new equilibrium for this particular situation? So what is a price floor? Let's write this as P bar is equal to 500. So just like how you have a price ceiling, now I think we discussed both the things, but I don't remember exactly if it was there in the lectures or not. But a price floor is just the opposite of a price ceiling. A price ceiling is that you cannot increase the price beyond a certain point, and price floor is where you cannot decrease the price below the certain value. So, like in this case, like in the case of a lot of agricultural produce, you have like something like support price or something like that, right? So there is a price, like a minimum price at which the produce will be sold in the market, in the mandi, and below that you cannot actually sell it. Like you cannot sell it for less than that. That is what a price floor is. In case that was not covered or not clear, this is a price floor. So now what happens now, because of the price floor, the quantity demanded and quantity supplied are both going to change, right? It's not going to be exactly the same. As the initial price was what we call as free markets, right? Free market is the term where there is no regulation, there is no price control, and the market is allowed to adjust and arrive at an equilibrium at some quantity and price where the buyers are willing to buy and sellers are willing to sell. That is what your general equilibrium is. But when you have some intervention, some regulation like this, then the market is no longer in that kind of an equilibrium. There is a new, like not equilibrium exactly, but you can say there is a new equilibrium. But in that case, QS and QD are not going to be the same. So first, let's calculate what is QD. Okay, P is equal to 1000. Oops. 1000 minus 2 QD. Okay, QD is equal to 1000 minus P bar on 2. QD is equal to 1000 minus 500. This is the quantity demanded, right? So you cannot sell more quantity of some good than what is the demand for it, right? So therefore, the quantity that is traded in the market will be QD. This is what will trade, but we still should we still should calculate. We do need to know what QS is also, and QS is given by P minus 100. Yeah, that is what I had got wrong. I had written 100 minus P instead. P minus 100 is equal to QS. QS is equal to 500 minus 100 is equal to 4. So now our new values are QS is 400 and QD is 250. So there is, you can see there is a big difference. There's a big gap between the quantity demanded and the quantity supplied. Now, in the case of a price ceiling, it is generally the other way around, that quantity demanded is more and quantity supplied is less, right? So there is a shortage. But in this case, because we have a price floor, there is an excess. You have a surplus. I mean, I don't like to use the word surplus because in world of economics, surplus means something else. But you can say excess is equal to QS minus QD is equal to 400 minus 250 is equal to 150. This is the excess. Now, as you can see, initially, when there was no intervention from the government or anything, quantity was what? Quantity was 300, right? Now the quantity has actually reduced and there is a surplus. So there is a um, lot of rice bags basically lying around which are not getting sold. Only 250 is getting sold, whereas more than that could have actually been sold in the general equilibrium. So this is just one of the takeaways. Let me see if there was any other
Ma'am,
question. Yeah,
ma'am, if it was the price ceiling,
yeah.
then how will we go about doing that, ma'am?
So if you're saying that if 500 was the price ceiling,
Yes, ma'am.
so if price ceiling is more than your equilibrium price, then your equilibrium is not affected by it because your equilibrium price is anyways not reaching that value, right? Now your equilibrium price was equilibrium P star is equal to 400, which is less than 500. So it is already less than the price ceiling. If P bar was price ceiling, no change. The whole purpose of a price ceiling is that you cannot charge more than that value, but you can charge less than that value. So if 500 is the ceiling and you're charging only 400, then there is no change in your transaction and there is no change in any excess or shortage. There won't be any excess or shortage.
Ma'am, in case the price ceiling is less than the equilibrium price, then what will be the case?
Then you will do the same thing I've done and you will find that there is an excess instead of a shortage. So if, say, suppose price ceiling is
300.
right, what was the price initially?
Ma'am,
400. So say
400.
suppose,
It is 400.
yeah, so say suppose the price ceiling was 300, then you again calculate QD and QS at that price. Then QD is 100 minus, sorry, 1000 minus, let's call this as P prime by 2, 1000 minus 300 by 2, so 350, and QD is equal to P minus 100, which is 300 minus 100 is equal to 200. So then you will have a shortage equal to 350 minus 200 equal to 150. Because demand is 350 and your supply is, sorry, this is supply, not demand. And supply is only 200. Because at that price, suppliers are only willing to supply 200 quantity. They're not willing to supply what the demand is. So then in that case, you will have a shortage. You will not have an excess. Okay, so let's go to the next question. So the next question is where you're given the market demand for textbooks, where P is the price of textbooks and PD is the price of digital books, which is a different product. It's not the same product, it's a different product. Textbooks here basically means physical textbooks, hard copy textbooks. So the demand is given as 100 by P plus 5 into PD square. So now you're asked first subpart to calculate the price elasticity of demand at the value given, QP is given. So what is the price elasticity of demand there? And then we'll come to the next part. So let's first do this part. I will mute myself for just 2 minutes and I want everyone to please attempt this. See, I can solve the questions and I can answer your doubts, everything. But the thing is, if you don't try to solve it, you won't have any doubts. And it will help you understand a lot better if you at least attempt to solve the questions. Because only when you attempt to solve them, you will understand what you're not understanding and what you're understanding. Sometimes I've seen that, I thought I don't know how to solve a question, but I at least started to solve it. And then I realized that I actually do know how to solve it. So it goes both ways. Not just what you don't know, but also what you do know, you're just not sure whether you know it or not. So that is why I always keep asking people to please attempt it at least. Okay, so I'll just mute myself for 2 minutes and please type in your answer. And if you're not able to figure out, you can tell me that also. I'll anyways solve it. Okay, so any luck? So we are given the function as q is equal to 100 by p plus 5pd square, where p and pd are parameters. Okay, and of course they are independent of each other. So when we take price elasticity of demand, what we do is we take, in this case especially, we will take partial derivative, not the full derivative, by q by p. If you want to report it with the sign, you can just take partial derivative like this. It will automatically come out to be with the sign. So we write it, we note it by epsilon. So in this case, it's already 100 by p, so it is minus 100 by p square upon q by p. So 1 p will get cancelled. What you will get is minus 100 upon q into p. We are given at what value we need to calculate it. Minus 100 upon values are given as 1000 into p is given as 400. So this becomes minus 1 upon 4000. So that means it is almost inelastic, right? Because it is very close to 0. It's a very low value. This is what we are calling as price elasticity of demand. Now let's go back to the question and see what the second question is. And the second question is asking that what is the cross price elasticity of demand of textbooks with respect to the digital books. So cross price elasticity tells you how the demand for that good changes the change in price of some other good. Now in this case, we are given the function as, let me rewrite the function. So cross price elasticity will be with respect to PD. I'm calling it as PD, and this is going to be equal to, or let me not put the sign, this is not necessary, it will be that, del q by del PD upon q by PD. It's the same formula. So what we are doing is we're just taking the partial derivative upon q by PD. So epsilon d is del q by del PD is 10 PD, right, upon q by PD. So what you get is 10 PD square by q. Now we're given the values of PD and q as 50 and 1000. So 10 into 50 into 50 upon 1000. This is going to get cancelled out. What you get is 25. Did I do something wrong? It's 5 PD only. 5 PD square. Yes. This is correct. Yeah, it's correct. If I had mistakenly solved it for a different price initially. That's why my answer earlier was different. That's what I was wondering. Okay. Any other Any other doubts in this? So in this case, I've taken the numbers like that you're getting it as very high value, which means that like we should be able to interpret the answer also. Why is it the first one is not? Because the demand is of textbooks, not of digital books. If you have a demand function of digital books in which you have the price of textbooks also, then when you take the derivative of that demand function with respect to P of textbooks, then you will get cross price elasticity of digital books with respect to textbooks. So I'm just answering the question which is in the chat box. Let me just read out the question. Why is the first one not called cross price elasticity of demand of digital with respect to price of textbooks? So that is my answer, that the demand function you're given is that of textbooks. If you need to calculate the cross price elasticity of demand of digital books, you need the demand function of digital books. Okay. So yeah, the last part of the question is that are digital books substitutes, complements, or neither for textbooks? What do you think? What do you think happens? Why is the cross price elasticity telling? What is the cross price elasticity telling you? So the direct way of interpreting it, even if I don't use any calculus, is that if you look at this function, and if you see in this function, an increase in PD is going to increase Q, right? PD is price of digital books. So that function is squared. So very easily we can conclude that any increase in PD is definitely going to increase Q. Now, an increase in a price of another good causing an increase in our demand for some other good is what kind of a situation? What does that remind you of? I think I explained it 2-3 times in the class. So if the price of another good is increasing, what option do I have? I have the option, if the price of tea is increasing, I may want to start drinking coffee then, right?
Aren't they complements?
No, they're not complements. Complements is when you want to consume both the goods together. So if you want to increase consumption of tea, you also increase consumption of sugar. If you lower consumption of tea, you also lower consumption of sugar. That is complements. But tea and coffee are what? Substitutes,
Substitutes.
right? Because
Yes.
if your price of some good is increasing and that is leading to a demand of some other good, then that means you're substituting that good with the other good. That is why it's increasing. And another way of saying that is that if your cross price elasticity of demand is coming out to be positive, then that means there is a positive change in quantity of this good. And in our case, it is positive. So, although, like I said, you don't even need to look at the cross price elasticity, just looking at the function itself, you can see that PD, increase in PD causes increase in Q. Hence, they are substitutes. Just So I've written it kind of symbolically. I'm not writing very long sentences. An increase in PD is causing an increase in Q, which means that they are substitutes. Okay, this was the third part. Let's go to the next question. Okay, this is the next question. And you're given the demand for the market demand for a pharmaceutical drug, and you are given the supply function also of the drug. First is what is the equilibrium price and quantity. This everybody can do now. I'll just mute myself and you can type in your answers.
दे दे बेटा.
Can everyone please mute yourselves when you're not speaking? Please unmute yourselves only to speak. Only one person has answered. Anybody else? Okay, two people have answered. Okay, so this is not a very complicated question. Write down the answer. So you're given demand as 1,000 and you're given sorry, give me a moment. My cat is coming. Yeah. You're given the supply curve as 400 plus QS. So as you can see, first of all, when your demand curve is sort of independent of price, that means that the demand is perfectly inelastic, right? That means the demand remains the same irrespective of the price. That is the first takeaway when you read this question, right? So QS is equal to P minus 400, or I mean, you can just calculate price also. You don't need to write this section. And from here, you can just plug in the value of QD as 1,000 because QD equals QS. So, okay, I'll come to the next part. Let me just solve this part first. 400. It's good if you have already solved it. You can type in your answer. I'll just look at it in a bit. Is equal to 1,400. This is your, so Q star P star is equal to 1,000 comma 1,400. Okay, let's go to the next part of the question. Next part, you have tau is equal to 50. So let's first look at what the curve is going to look like. So this is the axis Q P. So suppose this is your demand. This is what your demand curve looks like, right? And your supply is P is equal to 400 plus QS. This is P is equal to 400 plus QS. This is the supply. So what is going to happen now? You have, let me draw this again. Sorry, let me move this down. Otherwise, I'll be short on space. So, yeah. Now you have another um, factor in here, which is tau. So after tau, what is happening? Or before tau, let me first mark everything before tau. So this is your P star before any tax, and this is your Q star before any tax, right? So far, so good. Now we impose a tax, and the tax is on the seller. That is important to note. The tax is on the seller. I hope I have mentioned it somewhere. Yes, see, it says now if the government decides to tax a pharmaceutical company, that part is important because the incidence of tax is different from the actual incidence is different from the statutory incidence. So statutory incidence of tax tells you whose curve is going to shift. So in this case, because the seller is being taxed by the government, it is the supply curve which is going to shift. So this is the shifted curve now, and the value by which it is going to shift is tau. Okay, this is tau, or you can say this is tau. It's a bit untidy. So now you need to find this price. This price is what? Now, if you see, this is because your demand curve is a vertical line. This is the price paid by consumer, which is P star plus tau. That is the market price, right? Because we can see that after shifting on the curve, this is the new equilibrium. This was the first equilibrium, you can say E. Now this is E prime after shifting of the supply curve. So what we'll do to calculate the new price, the quantity remains the same. Quantity demanded and hence quantity supplied and supplied remains the same. Therefore, Q prime, let's say, is still 1000. What we'll calculate is PC, or price paid by consumer, is P star plus 50. Tau is 50. As we can see, the market price is what the consumer is paying. Oops. So this is 1400 plus 50 is equal to 1450. So is this much clear to everybody how we got to this? Any questions? Okay, now let's go to the third part where we are asked what is the producers and consumers surplus after the tax imposition, what is the deadweight loss, and what is the tax revenue generated by the government. Now in this diagram, I'll just shade it. Okay. In this diagram, if you see the producer surplus, let me just draw diagrammatically first before we calculate it, is basically the area between the supply curve and the price line. So this is your producer's surplus. It's not very accurate drawing, but increase it. Just representative. Now, if you see geometrically, you can probably see that even after shifting, if I mark this in a different color, this is the new producer surplus. And this is exactly the same as the previous value. You can see even diagrammatically, you can see actually my drawing is quite all right this time. Both the triangles are exactly the same, right? The area, you can say they're congruent, or you can say the area is exactly the same. So Producer surplus does not change. So we can calculate, oops. Yeah, producer's surplus is basically, you can take this value or that value, it's the same thing. Half into Q star into P star. Producer surplus is equal to half into, you can calculate whatever this comes out to be. The consumer surplus is the area between the demand curve and the price line. So I've actually explained all of this in a lot of detail in one of the classes. So I erased this also by mistakes. The consumer surplus, if I were to mark it on this, it will be this whole area. Why? Because the QD line and the P star line, they are not forming any closed shape, which means consumer surplus is infinite. This hashed part is all consumer surplus. And if you delete or if you remove some part of the producer surplus, sorry, if you remove some part of the area from this, see, when you're shifting, just temporarily write something. So when you're shifting, when you're the supply curve is shifting, this much part is actually getting lost in terms of surplus to the consumer, right? This much part is actually getting lost to the consumer. But because the surplus itself is infinite, infinite minus x is also infinite, right? Therefore, consumer surplus is basically just infinity. There is no other calculation involved here. Now let's go and calculate the tax revenue. Tax revenue is the part which I just marked with this bigger line. This is the tax revenue. It is just this triangle. It is tau into Q star. Just 50 into 1000, 50,000. And debt weight loss, as you can see from this diagram, producer surplus is not changing. Consumer surplus is not changing. So dead weight loss is 0. So as you can see, the main learning or takeaway from this problem is that, when you have inelastic demand, the entire burden of tax is on the consumer, because the price is changing for the consumer, right? It was 1400 and then it becomes 1450 after imposition of tax. Even when the tax is levied actually on the seller. So the tax has been levied on the seller, but it is not the seller who is actually paying the tax. It is still the consumer who's bearing the burden of tax. And the deadweight loss is 0. So basically, just the government gets a nice earning in terms of tax revenue from the consumer. Okay, so any doubts? Let me see the answers which we had. Yeah, you answered correctly. Somebody had posted on chat. Okay. Any questions? So we'll take a 5-6 minute break here, and I will leave question 5 on the screen and I will ask you to solve it. So far we have only been looking at demand and supply and taxes. Now we are moving to consumer theory and consumer preferences. So this is a slightly, it's not a very difficult question actually, but just requires a little bit of thought. So I'm going to mute myself and I will be back in 5-6 minutes. And you can, of course, type in your answers in the chat box in the meantime. Okay. Anyone has calculated anything? Let me write down the functions first. Okay, this is the given utility function. First thing you're asked is the MRS. Basically, you can say UX by UI. UX is marginal utility with respect to X. UI is marginal utility with respect to Y, which again, just to clarify, is del U by del X. This is del U by del Y. So this becomes 2 into 2x plus y. This becomes just 1 into 2x plus y. This whole thing gets cancelled. MRS comes out to be 2. So that was simple enough, I hope. Next part. The next part asks you that if the x is equal to 300, the y is equal to 150, and you can say the budget is equal to 1200, then what is the optimal consumption bundle? Now you can see that Px is greater than Py, and your utility function is 2x plus y whole square. So it looks like a complicated function, but actually the utility is nothing but a case of perfect substitutes, or substitutes at least. Whether you want to call it perfect or not is a subjective thing. Some books call it perfect, some books don't. But it's a case of substitutes. What happens in the case of substitutes when the budget function is also linear? Here your budget is what? Y is equal to x px plus y py. This is the first equation. You can call this the second equation. So when you have a function, if you plot even the utility function, it will be like you can ignore the negative values. So of course, negative x and y don't make any sense. So in our case, it's still going to be a straight line. So if you want, you can solve this geometrically. You can see the slope of u and the slope of the budget line, and then you can compare, etc., etc. Or you can just simply see when the price of x is more than the price of y, almost entirely, y will be consumed, x will not be consumed. Therefore, x is equal to 0. So if x is equal to 0, you just need to plug in the values from 2. I'm using the budget equation. Xpx becomes 0. Y you are given as 1200. Y into py is what? 150. Y is equal to 1200 by 150. What does that come out to be? That's all it's in there. Yeah. Comes out to be 8. So initially your x star y star is 0, 8. Then what is the next part? Then the question says that there is an increase in price of ice cream such that Py is now 400. Then you're asked the Marshallian and Hicksian demand vectors after the price increase. So let's do this step by step. So we calculated this before any price increase. This was your demand, right? This is your demand vector. Now mu Py prime, we can say, is 400. Okay, now one thing we will calculate before we move on to other calculations. Let's first calculate the initial level of utility. So u bar is equal to what? 2x plus y whole square is equal to x was 0. So 8 square is equal to 64. This was the initial level of utility. So what we do when we're calculating Hicksian demand is that we hold utility constant and then we find the new values of x and y. Now, we are given that price of y has increased. So py is greater than px now. Px was what? 300. Now py is 400. Therefore, what is going to happen? Y is equal to 0. Y will not be consumed. Only x will be consumed, right? So if you want to calculate the new Hicksian demand, what we'll do is, holding utility constant, we calculate the new value. Let's call it 2x prime y prime. Or instead of prime, we can just use the subscript h. So x is the only value. Now y becomes 0. So you have 4x h square is equal to 64. So xh is equal to 64 by 4. Sorry, xh square is equal to 64 by 4 is equal to 16. xh is equal to 4. xh is equal to 4 comma 0. Is this okay? Is it making sense to everybody? Now we calculate the new Marshallian demand. Marshallian demand, again, y is still going to be 0 because py is greater than px. We just, the fact that it's a coordinate solution makes things much simpler. Now, in this case, what we will do, we will plug these values in your budget function. Now, if you want, you can put subscript m here. I'm just leaving it like that for now. Your budget is still the same, which was 1200. Y is equal to 0. Therefore, x was what? 300, right? 300 into px. Sorry, 300 into x. I'm writing xm here just to differentiate it from. So, fortunately, in this case, you're getting Hicksian and Marshallian as almost the same. I mean, not almost the same, it is the same. Let me just check if I got it right. Yeah, earlier we had what? 0, 3. No, sorry, 0, 8. Oh, sorry. I 300 is the price of X, right? Did I take it as something else? Yes. I yeah, I got confused between 300 and 400. Yeah, so this is correct. So xm is equal to 4, and it so happens that in this case, your Hicksian as well as Marshallian demand vectors come out to be the same, but it may not always be the case. Just be careful. Okay. Questions? No? Okay. Let's go to the next question. So this question is again similar question, but we will do a slightly more interesting thing in this question. So this question, all the other questions are not from any book. This is the question from Perloff, from chapter 4. It's one of the questions. Which class would have covered the MNH demand vectors? Which class you mean, like which week video? I can't remember. I think week 7, probably week 7. Yeah, most probably week 7, if I'm not mistaken. I think week 6, 7, 8 covered this topic in general, but more specifically, week 7 talks about it. Which video I can't remember. There are so many. So yeah. Okay. So let's see what the question is. You're given a quasi-linear utility function, which is so by the way, this particular function and this particular problem is partially solved in Perloff. but the method they have used is slightly more tiresome method. I don't really like the method very much. In fact, I think they've not really explained it very well. But anyway, if you like, you can look at it. Um, but we'll solve it in a slightly simpler way in the class. So you're given the quasi-linear utility function for two goods, and you're given the total budget, which is 10. The initial prices are P1 equal to P2 is equal to 1. Then you are given that P1 then increases to 2. And you have to calculate the substitution income and total effect on the demand for Q1. So you're asking the name of authors of the books. So if you see the slides which I share, in every slide, there is a last slide where you have a reference reading. And in these are not online books, these are physical books, so I have not hyperlinked it. But in many of the other slides, I have given two online links also for reading. So my references are always there in the slide. You can look at it in the shared file. Okay, so I will just mute myself for a few minutes. I want everyone to please attempt this question and then we will solve it. Okay, let's start. Let's write the function again. This is question number 6, right? Okay. So a utility function is given as 4 under root x1 plus x2. So one thing important to remember is that whenever it is a linear composition of consumption goods x1, x2, xy, xz, q1, q2, whatever you want to call it as. But if it is anything in the form of ax plus by, any function of this type, then it is a case of substitutes. But if it is something in exponent, right? If ax to the power of alpha plus by to the power of beta, this is not substitutes. Sometimes this may also have a corner solution, but it's not the case of substitutes anymore. Okay, this is important to remember, which is why I took the question with a quasi-linear value. So, I mean, in your quizzes, etc., like I know many people take these courses for all different purposes, like to help with your course or just to understand economics, or if you want to pursue further studies in economics, or whatever your reason may be. Now, I don't exactly know what the format of questions everywhere else is. In your assessment, final assessment or final exam for this course, I know you're asked only MCQs, in which you will be given one option. So whatever I'm solving as the whole thing, this all is working, you will not be asked to show all this working. But then it's important to know, it's important to understand that working. And it's also a good idea to get into the habit of writing the answers with all the proper explanation for it. So let's go ahead. The first thing we will do in this case is, let's write the budget function also actually. Let's say y is equal to P1 Q1 plus P2 Q2. Okay, now let's first write the MRS is equal to MRP conversion. Okay, MRS is what? U1, or you can say MU1 by MU2 is equal to P1 by P2. Right? Now let's calculate MU1. MU1 is nothing but del U by del Q1. Del Q1 is what? 2 by root Q1. The differential of root Q1 is 1 upon 2 root Q1. 2 and 4 get cancelled, you get 2 by root Q1 upon MU2 is just 1 is equal to P1 by P2. So you can rewrite this whole thing as 4 P2 squared by P1 squared. This is your demand function for good 1. Now you're given, let me write the values also what we are given. P1 is equal to P2 is equal to 1 initially. So initially Q1 is equal to 4 into 1 by 1 is equal to 4. Right? Now we also have the budget. Let's write that also. Y is equal to 10. Right? Y is equal to 10 is given to you. So then from the budget relation, we can find value of Q2. 10 is equal to 1 into 4 plus 1 into Q2. Q2 is equal to 6. Therefore, initial values are 4.6. Now we are told that, let's read the question. Now, price of P1 changes to 2, right? Now, before, or let me erase this one. Let's calculate other things also in the beginning. So before we come to the price change, let us also first calculate the initial utility, right? Initial utility, let's call it as U bar. U bar is equal to 4 under root Q1 plus Q2. See, I have not memorized any of this. I'm just following the steps. Okay, there is a whole table in Perloff where you are given the demand functions for different types of functions, utility functions, but you don't actually need that. You just need to know what the approach needs to be. Similarly, when you're asked to calculate income substitution effects and total effect, what you will do is to find the total effect, you need the initial consumption values and final consumption values. To find the substitution and income effect, the breakup between the two, you need to know what the utility is, because substitution effect is calculated based on the constant utility, which is why I'm calculating the initial utility value. So U bar initial is equal to 4 into under root Q1 is what? Q1 was 4. 2 plus Q2 was 6. So 14. Initial U bar was 14. Now let's talk about next. Then P1 is equal to 2 change. Then we calculate the new values. Therefore, we use the same demand function for Q1, what we got before, which was what? 4P2 square by P1 square. 4P2 square by P1 square. P2 is still the same. So 4 into 1 by P1 is equal to 2. So Q1 comes out to be 2. Am I right? Just keep making sure I've not made any mistake. That's why I'm looking at. Because it just wastes a lot of time if I go back and correct it. P2 square by P1 square, sorry. Yes, I thought I was missing something. This is 4. And yeah, I missed out on the square. And so I was feeling something is off. I don't remember the answer, but I just remember that this is not the answer. Okay, so this is your next Q1 prime, let's call it. Okay, so this is the new equilibrium value, and Q2 is given by, let's write the budget equation again. Y is equal to P1 Q1 plus P2 Q2. So budget is the same when we're calculating the new equilibrium value, right? P1 is 2 into Q1 is 1. P2 is still 1 into Q2. So Q2 is equal to 8 now. You can write Q2 prime if you want. Therefore, Q1 prime comma Q2 prime is equal to 1 comma 8. I'm taking slightly more difficult questions in the review session just so you know how to approach it. In a much simpler question, all this calculation is going to be much easier. Okay, so don't worry if you're feeling like these things are a bit complicated or a bit difficult. It's okay. That is why I'm solving it in the class. Most likely you will not get questions of this level of difficulty, but this approach you should know. You may get a simpler question, but the approach you need to follow will still be the same. Okay, so if you want to know the total effect on Q1, because the price of one Q1 was changed, right, is equal to final Q1 minus initial Q1. Because 1 minus 4 is equal to minus 3. That's the total effect, right? Now we want to calculate the substitution effect. To find substitution effect, we find Q1 under constant utility. Okay, so if you hold utility as constant, Where is the function? 4 root q1 plus q2. Now, the thing is, even when you're holding utility as constant, the function we got for q1 was 4p2 square by p1 square. Now, when you're holding utility constant, you're also keeping prices as fixed. You have to remember. So when you're taking constant utility, we are also taking prices as fixed at the final value. That is by definition. It is not something we are assuming. When you're calculating substitution effect, draw the diagram. This is a rough diagram. Please remember that it's not a very accurate drawing. But say suppose this was your initial value. Now this is your final value. Say suppose this. Say suppose this is your indifference curve. This was your initial equilibrium. And so E1 was your initial equilibrium, and you're on that pink colored indifference curve. Okay. Now, when you change the price, when you increase the price, the curve rotates this way. This is the kind of rotation. So this it will move inwards, right? So now the new equilibrium will be E2. Okay. If we want to calculate substitution effect, we are moving along the indifference curve. That's the most important thing to remember. You're always moving along the indifference curve when calculating Hicksian demand or you're calculating substitution effect. And you're moving along the along the indifference curve, same indifference curve as the original equilibrium. What you're doing is you're compensating the person. Like I think I had explained this in the class also. Let me shade this. Which color should I use? This green. So this part of the opportunity set or budget set is lost to the consumer, right? So if you want to remain at that same level of utility, which is at E star is that point on the same indifference curve. You're on the same indifference curve, meaning same level of utility, where the prices are the new prices, but you're also holding the same level of utility, which is why you compensate. So this is the compensation. With this shift in the original, this imaginary line, this blue dotted line is the imaginary line. Let me show it properly this way. This blue line is the shift, imaginary shift of the budget line, such that you find the new budget or new income at which prices are the new prices and you're also at the same utility level, which means that we are holding prices. We're not doing something to prices. Prices were originally what they were, and then they were what they were afterwards, after the change. We are just moving along the indifference curve. So now, which means that in our case, even if you're holding utility constant, it so happens, in our case, it so happens that the demand curve or demand function for good one is still 4p2 square by p1 square, or you can say p2 prime square by p1 prime square. So the demand is still going to be what we calculated in the new original, in the new equilibrium. So 4 into 1 by 4 is equal to 1. Or you can call this as I don't know what you call it, Q1S, let's call it. Are you understanding what I'm saying? It's a little confusing, I know, but I hope you do get it. So I'm trying to make it visually also the same. It's not exactly, the diagram is not exact, but if I draw it like this, then in our case, this is how it is coming out to be. That E star and E2 are in the same vertical line coming out to the new Q1 prime which we got. Okay. Okay. So in this case, substitution effect is equal to original Q star minus Q1S is equal to, or sorry, the other way around, Q1S minus Q star. 1 minus 4 is equal to minus 3. Therefore, total effect is equal to substitution effect plus income effect. Total effect we knew was minus, not 3, sorry, not minus 3 is equal to minus 3 plus income effect. Therefore, income effect is 0. This time my diagram is actually quite acceptable. So I hope it is clear. Let me show it like this. This shows the shift a little better. Let's mark the initial value. Okay, any questions? No questions? Either everybody has really understood this or have not made any sense to you. Which one is it? Okay, so I will be uploading this video again. If you have any confusion, you can go back and look at it again. But I hope you have understood it just for your sake, if nothing else. So that is what it asks. It asks for substitution income and total effect. And this is how you approach it. Okay, next question. So the next question is we move to producer theory. You're given a production function in two goods. First question is under what conditions on alpha does the firm have constant returns to scale? Next is what is MRTS, and then last is the values of X and Z, optimal values of X and Z for the given values. So I'll give you 2 minutes to solve this. At least the first two parts everybody should be able to solve. Actually, this whole question is really not difficult. We have solved these kind of questions in the class already. So I'm going to mute myself and I'll let you solve it for a few minutes. Okay. Nobody solved it? Let's write the function. Q is equal to 5x plus z to the power of alpha. So first question is just asking you what happens to alpha when you have constant returns to scale. So for CRS, you can say f of x1, let me write, tx1 comma tx2 is equal to t times f of x1 comma x2. That is the basic definition of CRS. Yeah, x1, x2 can be any inputs, any two inputs. In our case, it is given that it is x and z. We can write q as a function of tx comma tz is equal to, replace x by tx, tx plus tz to the power of alpha. So 5tx plus t to the alpha and z to the alpha. Now we can see that if we can take t common here, we have 5x plus t alpha minus 1 z to the power of alpha. Now we have taken t common. Now what we need is, we need this expression to become q of uh, t times q of x. So what we want is that for CRS, let's rewrite the expression. Actually, this question, I'm showing the whole steps and everything, but you can answer this question just by looking at the function. Actually, you don't need to solve all this. Of course, if you're asked in a subjective exam, you will need to solve it, but this is the condition we need for CRS. How can we get this condition? We need this function should be expressed in terms of q, original expression, which is possible only if t to the power of alpha minus 1 is equal to 1. Only in that case, this is alpha minus 1. Only in that case, or you can say it is equal to the power of 0, then our condition is satisfied. Okay. Therefore, alpha minus 1 is equal to 0. Therefore, alpha is equal to 1. Which means, therefore, q is 5x plus z. In this, now you see, if you multiply x by 2, z by 2, what do you get? 2 times of the whole thing, which means it is CRS, right? So this is a very, very simple question. Actually, this is not a difficult question at all. I have just maybe given you a function which looks like a difficult function, but it is not. If you look at it, if alpha, you just forget that there is any alpha, which means that to the power of 1. It is a case of perfect substitutes if alpha is equal to 1. If alpha is not 1, then of course it is a different thing. But for CRS, that is the condition and that is how we get it. Okay. Next question, next subpart, I mean, is asking us what? MRTS. So you have marginal product with respect to x upon marginal product with respect to z. X and Z are our inputs. So it's equal to del Q by del X, del Q by del Z is equal to, where is our function? Let me put function again. I have x plus z to the power of alpha. So here you have to answer in terms of alpha. So this is 5 alpha to the power of, sorry, alpha into z to the power of alpha minus 1. That's it. That's your MRTS. It's nothing more to it. Next part is that you are given input prices of Px equal to 15, Pz equal to 50, and you're given alpha as 2, and you're given Q as 100, and you're asked the values of X and Z. So now, first thing we can do is we can use the MRTS condition. Just plug in the value of alpha as given. 5 by 2 Z is equal to Px by Pz, right? Px by Pz is 15 by 50. Now, you can just simplify the value of Z from here itself. Actually, you don't need to do anything else. This becomes 3. Something like that. So generally from MRTS and price condition, you get some relation between X and Z, but this is a special case in which you are straight away getting the value of Z because the function is like that. Now, how do we calculate the value of X? That's simple now, you know the function. So we're given the value, just plug in all the values, and we can just calculate this, whatever this comes out to be. This is this comes out to be 6.112. So that is your answer. Any doubts? Any problems? Okay, let's go to the next question. So this is a fairly recent theory. We discussed this theory of cost functions just in the last class itself, just 3-4 days ago. Now in this question, you're given the cost function of a firm, this 200 plus 2q square, and you're given the market price of watches, and you're asked how much, like what the quantity produced should be. So I'm hoping this is something everybody can calculate. So can somebody please tell me how you will proceed over here? So we already did this. I'm just writing it, I'm doing it in short a bit quickly because I think we've gone over these concepts a lot of times. So marginal cost is equal to average variable cost only at Q equal to 0. Therefore, at Q greater than 0 and P greater than 0, firm will operate. And marginal cost is equal to 4Q. So if Q is greater than 0 implies marginal cost is also greater than 0, which is price is greater than 0, firm will operate. Therefore, at P is given as 100, right? P is equal to 100. P is equal to marginal cost. 100 is equal to 4Q is equal to 25. What is profit level? Profit is equal to P into Q minus cost. 100 into 25 minus cost is what? 200 plus 2Q squared. What is this value? This is 1250. Of course, climate as so profit is also equal to 1250. And third part actually we already did that. What is the minimum price? Firm operates at P greater than 0. It's asking positive output. In case the question is framed as something like positive profit, then you will of course check all the other questions. Yes, so this question is taken from the chapter on perfect competition. Here in this, it's actually written. Suppose you are the manager of a watchmaking firm operating in a competitive market. So that's it. There's no assumption there. It will be given. Mostly it will be given. So here we are given that it is in a competitive market. I think maybe you were not, you shared the question for a short time, so maybe you didn't see it. But you will generally be given because the way you approach it, if it's a monopoly or if it is an oligopoly, will be completely different. So this is anyways a question from Pindyke and Rubenfield. If you want, you can look at it, but it's a pretty straightforward question. I think we solved much more complicated questions in the previous class, so I don't, yeah, I don't think this question would have much of, will give too much of trouble. So this is the answer, and I think I'm at the end of my question list. So we will meet again on Tuesday because we still have week 12 to cover. And it was not possible for me to cover week 12 as well as the rest of the course today. So I just decided to recap some of the more difficult concepts. So if today's class felt a little bit difficult, it's by design because I wanted to pick up the more difficult or abstract concepts in the course and sort of discuss that once in the class today. The easier parts, I'm hoping that the class videos and the tutorial videos will be sufficient to help you, and you also have a reading list. So any doubts or questions, anybody? So this video will be updated in that same sheet and on the same YouTube playlist. If anybody wants to review it again, you can do that. Okay, if there are no more doubts, I will end the class here, and hopefully I'll see all of you on Tuesday. Okay, thank you everyone.